Hello students, today I shall discuss about integrated rate equations. We have already studied about differential rate equations, but in case of instantaneous rate, the order of reactions cannot be determined by the slope. Therefore, we study about integrated rate equations. Integrated rate equations are different for different order of reactions. First of all, I shall discuss about zero order reactions. Zero order reactions. In case of zero order reactions, the reaction rate does not depend upon the concentration of reactant. Let us consider the general chemical reaction in which reactant R converts into product P. Here the reactant R converts into product P. Now the differential rate equation R is equal to minus dr upon dt is equal to k r to the power 0. Here the r power is 0, which shows that the reaction rate does not depend upon the concentration of reactant. Now we have dr is equal to minus a dt. Since r to the power 0 is equal to 1, therefore we have k into 1 is equal to 1, thus dr is equal to minus a. Now integrating both sides, we have r is equal to minus at plus I. Here I is a constant known as integration constant. The value of integration constant can be obtained by applying the initial conditions. At t is equal to 0, when the reaction starts, the concentration of reactant R is equal to R0. Concentration of reactant R is equal to R0. If we apply initial conditions into this equation, we obtain R0 is equal to minus a into 0 plus I. Therefore, I is equal to R0. The value of I is equal to R0. Now put the value of I into this equation. We have R is equal to minus at plus R0. This equation can be compared with this equation of straight line. Y is equal to mx plus c. Here the intercept is equal to R0 and slope is equal to minus k. Now if we plot time against concentration of reactant, now if we plot time is on the x-axis and concentration R on the y-axis, then a straight line is obtained. The slope of this straight line is equal to minus k and the intercept is equal to R0. The intercept is equal to R0. From the slope of this straight line, we can obtain the value of rate constant. The value of rate constant can be determined from the slope of this equation. If we plot time versus reactant concentration in case of zero order reaction, then from the slope we can determine the rate constant. This equation can be rearranged. R0 minus R is equal to K divided by, this is divided by T. On rearrangement, we obtain K is equal to R0 minus R upon T. From this equation, we can also calculate the rate constant for zero order reaction. If we know the initial concentration of reactant and concentration of reactant at time t, then we can determine the rate constant for zero order reactions. Zero order reactions are generally uncommon Some examples of zero order reactions are reactions occurring on the metal surfaces. For example, the decomposition of gaseous ammonia into nitrogen and hydrogen over a platinum surface at elevated temperature is an example of zero order reaction. In this reaction, the reaction rate does not depend upon the concentration of ammonia. The ammonia at high temperature gets saturated on platinum surface, therefore the change in reaction conditions does not affect the reaction rate. Some enzyme catalyzed reactions are also examples of zero order reaction. The decomposition of hydrogen iodide over the metal gold surface is also an example of zero order reactions. Hydrogen iodide decomposes into hydrogen and iodine at the gold surface. This is also an example of zero order reaction. Here the reaction rate does not depend upon the concentration of hydrogen iodide. So we have discussed the integrated rate equation in case of zero order reaction. In case of zero order reaction, the rate constant K is equal to R0 minus R upon T. Here R0 is initial concentration of reactant, R is concentration of reactant at time T. We can also determine the rate constant K from a plot between time and reactant concentration. From this slope we can determine the rate constant. Thank you.